Hi everyone, how are you doing? Okay, great. So today we will solve many questions on simple linear regression, right? I mean, you people have understood that what is a simple linear regression, but now we are going to solve many questions so that you get to know more. Okay, okay. So let's just get started. Now, let's see this particular question. So what they are saying. Consider two data sets shown below. So there are the two data sets. When fitting a linear regression model to predict y-axis value as output, given x-axis value as input. Okay, so basically this is an input and this y is an output. Which of these two training set will show lowest training mean squared error? Okay, MSE means mean squared error. Circle your answer. No need to provide justification. So which one you think will provide least mean square error or the lowest mean square error in the training set? Because they have given the training set only, right? Okay, so it is clear that whatever we do in the data set 2, we can't be having, I mean, lower than D1, because assuming the number of points are same, because here it you can very well, fit the line. So it is easy question, right? So you can very well fit the line, and then you can say that, okay, this is, okay, whatever is the best line, you can say, see, this is the best line, right? Here, even if you try to fit, in whatever way you try to fit, I don't know, maybe this might work, I don't know, right? Maybe this might work. So in whatever way you try to fit, it won't be a better line than, I mean, it won't be having the better training error than D1. So D1 is the answer, right? I hope that is okay to everyone. It is an easy question to start with. Okay, so D1 is the answer since the line of best fit lies closer to the training points in the data set. Thus the squared error of the best predictor will be smaller, right? Let's do this question. What they're saying, what is mean square training set error of the of running linear regression on this data using the model y equal to w naught plus w1x. So in this particular data, actually everything is linear, which means everything is on this line. Okay, data is in such way. So what do you think, what will the mean square training error? It will be zero, right? It will be zero. Yes. So it will be zero because there is no error, right? So even the point that is at the end, which is like here. Okay. I'm sorry that I can't draw properly here. Okay. So this will be the final line, right? Yeah, y equal to x. Now what they're saying, what is the mean square test error? Okay, this time they are saying test error. Uh, I hope that's fine to everyone. I can remove the line also. What is the mean square test error of the running linear regression on this data, assuming rightmost 3 points are in the test set and others are in the training set? So they're saying this is in the test set and others are in the training set. So you don't see them, right? You don't see them. Then what you will say? Again zero, right? Because the line will be same. Okay, the line will be same. Again zero. Is this okay, everyone? Okay. So both are having zero as an answer. Now let's suppose instead of, okay, I mean, just for the sake of variation, by the way, both are having the zero as an answer. It's an easy question, but just to get started, right? But just as an variation, suppose I say that uh, that instead of these points, right? Maybe let me draw the points with my choice. Let's suppose I have points like this. I have 1 point here, for example. I have 1 point here. Okay. I have another point, let's suppose here. And probably let's suppose, okay, 1 point here, which is, let's suppose, linear to this. Okay. So this is y equal to x. Let's suppose one more point here. Okay. So these are the 2 points that I have. And let's suppose there is 1 point which is here. Okay. Which is this one. Now, suppose if I ask you, let's suppose this is point number A, this is point number B, this is point number C. In this case, if I ask you, if A, if train set, okay, train set, suppose this point is 5, 5. Okay. If I say that if train set has A and C, right? Then what is the train error, train set error or train error? And what is the test error? Suppose if I ask you this, and what is your answer? And my next question is this: if train set has A comma B, then what is the train error and what is the test error? Okay. So in this case, if you see the train error, right? The train error, if it is having A comma C, then training will say that okay, it is linear, so the final line will be this, right? So that's why the train error will definitely be zero. Is this okay to everyone? The train error here will be zero. Let me know if that is fine. Okay. What will the test error? Test error will be at this point. Okay. I mean, the remaining point is the test point. Okay. So the test error will be at 2. What I'm predicting at x equal to 2. What I'm predicting? My prediction is bicap. Okay. So, so here I'm writing at x equal to 2. My prediction is bicap. So what I'm predicting bicap is, can anyone tell me? Bicap is also 2, right? Because y equal to x is our line. And what is real y? What is the real y? It is 0. So what you can do, you can take the difference between these two, which is 2. So 2 minus 0 whole square divide by the number of test points. Okay, I'm taking, let's suppose mean. Mean means average. Okay, mean square error. So divide by 1 only. So what is the answer? Answer will be 4, right? Answer will be 4. And what about this? If train has A and B, then what is the train error? Again, these 2 points are collinear. So that's why again here is 0. And what about the test error? So since the line is just constant line, right? What is the line? The prediction here is that y equal to 0 is the line, right? This is the line. Okay. Here y equal to x is the line. So what you are predicting? I mean, this is y cap. Okay. So what you're predicting, you're always predicting 0, but what is the real at x equal to 5? At x equal to 5, real is 5, right? Real is 5. So real is 5. So you can say at x equal to 5, real is 5. Okay, the actual ground truth, we call it ground truth also. Okay, so real is 5 and the predicted one is always 0 actually, right? So it will be 25. So the answer is 25. Understood? So either here 25 is the answer, here 4 is the answer. Okay, let me know if that is okay to everyone. This is answer. Okay. Is the question clear to everyone? That what I'm saying? Okay, I'm just saying if A and C are in the train or A and B are in the train, just a small variation. Okay, so that you get to understand this linear regression more carefully. Now let's just solve this question. What is the denominator one here? Because we in the mean square error. Okay, this is called MSE. MSE means mean. Mean means average. See here, we call it mean square error. Mean means average. Okay, MSE. See in the previous question they have also written the short form MSE. MSE means mean square error. So which means that you will take the square and then you will take the average of the squared errors, right? So since the average means that number of elements, you need to divide with the number of elements. Since there is only one test element, so I'm just dividing with one. Okay, because there is only one test element. Okay, now let's do this question. Consider the following data with this input and output. What is the mean square test set error of running linear regression on this data? So suppose this is the model that we're trying to fit. Okay. So what you can do, you can obviously run the mean square or run the linear regression, and then you can find out these coefficients which are W naught and W1. This is what you can do, but they have given you hint. They are saying that by symmetricity, it is clear that best fit of these three data points is a horizontal line. Okay. So they are saying the best fit seems to be the horizontal line. Only this much hint they have given. Now, can you tell me which horizontal line is better? For example, For example, if I just tell you that okay, this is the data that you have, will this line be better, or will this line be better? Let's suppose 1.5. Which one could be better choice? Or maybe somewhere between 1.5. I mean, you can just tell me the answer, whatever you are thinking. Okay. So suppose this is y equal to 1.5. Suppose this is y equal to 1. I think at y equal to 1, the vertical distance, right? The vertical distance will be your final answer. It is 1 and this is 2. So 1, right? So 1 square is just 1. So only the train error, if I say, then the 1, right? I mean, for y equal to 1, the train error seems to be 1. Let me just write it. For line y equal to 1, the train error, let's suppose this point is B, this point is A, this point is C. Train error will be at B, which will be vertical distance, right? So at x equal to 2, you are actually predicting, you are predicting y equal to 1. Always you are predicting actually y equal to 1. But the real one is 2. So 2 minus 1 whole square, which is 1, right? I mean, divide by 1 if you want to do it. Others will be actually 0. I mean, if you want, sorry, not divide by 1, this will be divided by 3. I mean, always divide by 3, because in the train we have 3 points, right? So 0 square plus 0 square divided by 3. Okay. For line y equal to 1.5, the train error will be at how many points? A, B, C, right? At A, B, C. So at A, it seems to be uh, this is 0.51, 0.5 square plus 0.5 square plus 0.5 square. Okay. So 0.5 square plus 0.5 square plus 0.5 square. I mean, divide by 3, you can just ignore. If I'm just comparing, then you can just ignore. Doesn't matter. This actually constant doesn't matter. But yeah, if you're taking mean, then you can divide by 3. Ultimately, these constants actually won't matter. So, what is the answer? This is 0.25. This is 0.25 plus 0.25. I think this is 0.75, right? This is 1 by 3. Or maybe I'm just omitting this 3. I hope you don't mind it. You will get to know later on that just for the comparison purpose, this constant doesn't matter, okay? Just for the comparison purpose. So this is 0.25 plus 0.25 plus 0.25, which is 0.75. So I think this is better, right? So I think this is better. So probably y equal to 1.5 is the better choice. Okay. So let's just go with the 1.5. You can check with 2 also. I think 2 is even worse, because it will even be more than y equal to 1. So I think 1.5 is better choice. Why are we omitting 3? I didn't get your question. So what is the answer? 1 by 3. Okay, from I think they're having 1 by 3 distance and then 2 by 3 distance. So somewhere 1 by 3. So the total distance is 1 here, right? Okay. So actually neither, I think that was the answer. That was 1 by 4. That was giving us 1 by 4. Okay. But yeah, the total distance, the vertical distance from this is 1. So they are saying somewhere which is 1 by 3 above than this and 2 by 3 below than this. Okay. So, I mean, ideally, we obviously have to find out the values by the calculation. Okay. Don't worry. Like here, I'm just taking as a final answer. So they are saying y equal to 1 by 3, which means 1 plus 1 by 3 is how much? So 1 by 3 above than this, which means 1 plus 1 by 3, which is, I think, 4 by 3, right? Okay. So y equal to 4/3. Okay, seems to be best choice here. Obviously, ultimately we need to calculate this w0 and w1. You can just ignore this w0 because they have given you the hint. Then you can find out the value of w1. How? By the calculation. What is the calculation you need to do? You can do y minus y cap whole square, right? For all the points. So basically, the first point is, for example, the first point is this one, which is actual is y minus wx. This is just wx, right? So minus w whole square plus the second point is y equal to 2 minus 2w whole square plus the third point is y equal to 1 minus 3w whole square. So you need to differentiate this and then equate to 0 to find out the w. Okay. I'm just keeping the bias, which is w naught to be 0. I'm just keeping the bias to be 0, and then you can differentiate this and then find out the value of w. Is this fine to everyone? Okay. So if you differentiate this and then if you find the value of w, it seems like that y equal to, so this is wx, right? Sorry, I think I did it wrongly. W1 is 0. Yeah, W1 is 0 and W for W naught actually you want to solve. For W naught you want to solve, right? So this will be W naught. Yeah. So slope is 0. So W1 is 0. This is also W naught. Yes, you are right. Okay. So if you solve this, then W naught will come out to be 4/3. Okay. Is this fine to everyone? How to solve this? Okay. So then you can calculate SSE. SSE is means that without the mean, okay, without the mean, it is called sum of squared errors. It is just sum. Okay, S means sum. If you take mean instead of sum, then you will divide by the number of elements. Okay, this S means sum. This M means mean. So you can do anything, doesn't matter. Okay, now let's just see this question. What they're saying: consider a data set, just a usual data set where xi and yi are the real valued I. And data is modeled like this, which means yi cap equal to w naught plus w1 xi. Okay, okay, just a usual thing. Now you might have noticed one notation here, which is argmin. How many of you know this notation argmin? Okay, so you might know about min, right? What is minimum of x square plus 3? What is minimum of x square plus 3? Can anyone tell me? This is 3, right? This is 3. Can anyone tell me what is argmin of x square plus 3? What is argmin of x square plus 3? So argmin means that what is the argument or what is the value of x that is making it to be minimum. So this is 3, that is fine. But what value of x making it minimum? X equal to 0, right? So 0 is the answer here. This means the value of x. Okay, argmin means value of x. And min means value of fx, right? Okay, the minimum value of fx, you can say. Okay, the minimum value of fx. Here, the value of x which makes fx minimum. Okay. Is this fine to everyone? What does this argmin mean? Argmin means like x, value of x actually. Okay. That's all. So for here, if they are writing argmin, it means the value of w0 and w1, which are making that to be minimum. Okay. So what they're saying, assuming that solution is unique, which of the following statement is true? Okay. So this is the loss function they have given. Then which of the following statement will be true? You need to basically differentiate it. Okay. Just try to differentiate it. So if you differentiate, let's just try to differentiate with respect to what you will be differentiating. Can anyone tell me with respect to what? No, X is the data, right? You need to differentiate with respect to W0 and W1 both. Okay. So you need to differentiate with respect to W0 also, W1 also. So let's just differentiate with respect to, for example, W0. Okay. And here let's just differentiate with respect to W1. So if you differentiate with respect to W0, then what will happen? Okay. So see, this is just scalar. Now, I mean, there is no vector and anything involved here. Tell me, in the simple linear regression, do you have vector or something? No, right? You just have scalars. So what will happen if you differentiate this? See, this W naught is constant, not constant, I mean the similar among all the summation terms. So if you're ever confused, okay, for the summation, what you can do, you can just open up the summation for example, two quantities, y1 minus W naught minus W1 x1 plus y2 minus W naught minus W2 x, sorry, W1 x2. Is this fine for everyone? I mean, just for two quantity, for the sake of understanding, I'm opening it up, right? I mean, there will be whole squares. Is this fine? Now just differentiate. Now you can differentiate. If you differentiate this now with respect to W, anything, okay? For example, W naught for now. Now, what will happen to the first quantity? It will be 2 into this one, W1 minus W naught minus W1 x1. And then you need to multiply by the what quantity? Minus 1, right? Is this fine? Let me know. Right? You need to multiply by minus 1 plus. The similar thing will again happen 2 into W2 minus W naught minus W1 x2 into minus 1. Is this fine to everyone that how we are differentiating with respect to W naught? Everything is scalar. Here, everything is scalar. There is no vector involved. It should be easy for all of you because it is, like simple calculus, right? Now you can bind it again in the summation format, which means if you try to bind it in the summation format, what you can say? Okay, I mean, this is probably just for, you can say one or two examples. Otherwise, you can directly write the summation format only. Okay, which means for all I, what you will be doing, this is minus 2, right? Minus 2 into, basically it is minus 2, or maybe let me just write 2, the similar thing, right? 2 into y, instead of y1 I'm writing yi minus W naught minus W1 xi, okay, into minus 1. Is this fine to everyone? I mean, instead of y1 here, I'm just writing yi, and this will automatically follow, right? So is this x going to be vector? Let me just clarify this. See, in the simple linear regression, let me just clarify again. Okay, in the simple linear regression, what happens? You have uh, only one D data, right? Only one D data, which means you have X and Y, right? So here we call this first example. We call this first example at X1. Okay, let's suppose this is the first example, right? I'm calling, let's suppose it's X1. For example, I will say, let's suppose this is 2, this is 5, this is 6, this is 9, anything, right? I will say yi equal to W1 into xi plus W naught or B. Okay. I mean, you can write anything. Is this fine to everyone? Now, here, is there any vector involved? No, right? Then the mean square summation or mean square error will be, sorry, I might have written like this by I, but it is actually by I cap. In the sense, it is our prediction. Okay. This is not the ground truth. So mean square error is by I minus by I cap whole square divided by summation divided by n. Is this fine to everyone? Let me know. right? Now you see one thing. Okay. Now you see one thing, that this is what? This is, some number square, right? So can I say this as some y. Okay, here let's suppose this y is a vector if I'm not writing with any subscript, minus y cap. Okay, these two y's are vector, transpose y minus y cap. If I want, can I say, I mean, it is my choice. Okay, if I want, can I say like this? Don't worry about this n. Can I just remove this n? Okay, I mean, just removing for the sake of, writing. I hope you don't mind it. Okay, let me write SSE. If you're taking the summation, let me just SSE. Okay. So, I hope that's fine to everyone, right? So here, if you're writing in the simple linear regression, if you're writing like a summation format, right? If you're writing like a summation format, then are you working with any vector? No, right? If you're writing like yi, and this yi cap is definitely, as you know, it is w1 xi plus b, right? Or some people write w naught, which is fine. Okay. I mean, this is just a notation. Okay. So your summation of the squared error will become something like this. Will become something like this. It is actually same as saying yi minus w1 x1 plus w naught whole square, right? For all I. Or in the vector format, you can just write like this. Okay. So these two formats clear to everyone? That if you write as a summation, you can write like a scalars. Okay. If you prefer to write in a vector format, you can write like this also. Don't worry, it is just, beginning. You will get to understand everything very clearly. Okay, this is my promise. You just take my words very clearly, you will get to understand everything. Okay, just have some patience. So here, how to, understand it is vector or it is scalar. Don't worry, this simple linear regression is just beginning, and we will see the multiple linear regression, and then the things will be very clarify that okay, this is a matrix notation, this is vector notation, like that, right? So here just see that okay, if I'm writing with a subscript, then most probably, until and unless they just make the very bad notation, okay, they just abuse the notation, until and unless that, most probably they're talking about the scalars. Here we have the scalars only, right? Yes, it will be for all the examples. Let's suppose this is one example number one, this is two, this is three. Let's suppose we have capital N, okay, or a small n, whatever. It will be one to capital N. Okay. If we have capital N examples. Okay. Now, I hope this notation is clear to everyone. Here we have scalars. Okay. Currently, we have with the subscript, we have scalars. This is a scalar. This y is our ground truth. This is also a scalar. This is our. Can anyone tell me what we are saying this? I mean, what we are writing this? Yes, yes. We are writing y1 cap. Okay. Or yi cap or the predicted one, right? Okay. So we are writing with the cap just to make sure that okay, we are not mixing with the notations. This is y2 cap. Okay. So if you differentiate, actually you don't need to open up and then you don't need to mix. It is too much of the work, which means I want to differentiate this, then just think like this, that the differentiation will come within this. Okay. The summation will remain as it is, which means that you just differentiate directly this term in terms of I. In terms of I, you differentiate. Okay. So you can do all of this process, but it's not actually needed. In terms of I, you just try to differentiate with respect to W naught. You just keep the summation as it is for I. I'm not writing 1 to n. I hope that's fine to everyone. Now, in terms of I, directly differentiate it. So 2 will come, I think, here. And then with respect to W naught, minus 1 will get multiplied. Is this fine to everyone, this differentiation? Right? Similarly, you write like this, summation like this, and then 2 will come definitely up front, which is yi minus W naught minus y1 xi. This time, you need to differentiate again with respect to W1. So what I need to multiply? Minus xi, right? Minus xi. Okay. Is this fine to everyone? Okay, so both of them I need to set to 0, right? I mean, these are the set of equations generally we need to solve. So let's just do one thing. Let's just, copy this particular thing on the next page and let's just see what is happening. So they want us to know that which of the following is true. Then what we are doing, we are just trying to differentiate and then we are seeing that what is the correct answer. Okay. So when we try to differentiate, we are getting this, something like this. Then this is 0, this is 0. They are saying which of the following is 0. It could be MSQ question also, but I don't know. It is okay. Just assume this is MSQ here. Okay. I mean, there is no harm in assuming this is MSQ. Okay. Now, this 2 is anyway common. I think -2 will go to 0. That's not very relevant here. So yi minus, okay, multiplied by yi should not be any option, I think. Multiplied by xi square also not be any option, valid option. I think C seems to be the correct option. This square also won't be the correct option. So what is the correct option? I think C is the only correct option, right? Okay. You just need to differentiate and can check it, right? With C, I think this is fitting, but they can definitely give you this also as one of the option, right? Can they give you this also as one of the option? Tell me. Okay. Okay, great. By the way, what is this? What is this number? We called it something. I mean, it is not necessary you know the technical name. Yeah, error. Yes, error, residual, or whatever you want to call it, right? So error or residual, or whatever you like to call it. So you notice one thing, that the summation. Okay. So this is so perfect line that you are trying to find out. Okay. I mean, trying to fit that the summation of all the errors, right, is actually error or residual. I mean, I don't think that this name is important. Okay. Yes, -2 will go to the 0. You can see here the very interesting finding we can do here, right? Very good property or whatever you like to call. You can say that summation of all the errors are actually 0. Okay. So this tells us that summation of all the errors are 0. Isn't it a nice property we have discovered? That whatever the best line is such that the summation of all the errors are 0. Is this absolute error? Tell me. Is this absolute error? Has to make sure. Absolute means you have to put the modulus. Absolute error, summation of absolute error can never be 0, right? Until and unless it is collinear. This is not absolute error. I hope I'm correct with my terms. Absolute means modulus, right? So is this absolute error? Let me just call it signed error. Okay. Signed distance or whatever. Or maybe let me just call it directly error. Okay. All the errors should be 0. Okay. Just a nice discovery we have done, isn't it? So it's a nice finding that summation of all the errors are 0. Is 0 actually. Okay. So don't worry, everything will come in, fall in the place. Okay, slowly everything will fall in the place. Don't worry. Let's just be with me, and you can just solve more questions with me, and see if you are able to understand the things. Is this fine that C is the correct answer here? Okay. Now, let's just see this question. I mean, the same question we have, I think. But what they're saying this time, they're just modifying this. Interestingly, they're modifying the loss function itself. They're saying the loss function have alpha I. What is I here, by the way? I equal to 1 means what? Uh, okay. If you guys do not disturb much, I can just open your mics if you want to communicate. It will be better. Okay. So, can you can you make that harmony? Okay, don't do it or don't overdo it. Just make the proper use of this, right? Okay. So anyone wants to speak that what is the I here? I equal to 1 means what? Okay, you can quickly speak. It's not an issue. Okay, don't be afraid to get wrong or right. Okay. So what is I? I is the data point number or the sample point number, which means the example number or observation number, which means I equal to 1 means the first data point, second data point, third data point, like this, right? So these are the I. So what I'm saying here is that I'm multiplying some positive number alpha I square, or if you are confused with this alpha I square, you can just say alpha I. Okay. I mean, this is just some number. You keep it square, you don't keep it square. It doesn't. I don't think it will matter. Okay, it's just some positive number. So basically, you're multiplying some alpha I square, which means it might depend on data point to data point. For example, that you have some data set. Okay, you have some data set such that this is x, this is y. This is, let's suppose, 1, this is maybe 2.0, this is, let's suppose, 2, this maybe, let's suppose, 3.6, this is 3, let's suppose this is 5, this is 7, this is, let's suppose, uh 3. Okay, just some random data set I'm making. Now here we are definitely doing some prediction, which means we are trying to fit some line which is looking like this: w1x plus w naught. Okay. I mean, this is up to you. You write w1x plus w naught. Or I think we started with the notation which was wx plus b. Okay. You can do anything. Actually, in the multivariate, when we go to the multi-linear regression, in that case, we will be having w1, w2, w3, like that. So I think it is better to start looking at it like this. Okay. I mean, it's your choice. It doesn't harm to make use of any notation. So what I'm trying to say, that let's suppose you make this alpha 1. So here you will be having alpha 1, here you will be having alpha 2, here you will be having alpha 3, here you will be having alpha 4, and so on, right? What you can do, you can put based on your choice. Let's suppose you are making it 1, let's suppose you are making it 5, let's suppose you are making it 10, let's suppose you are making it 2. Okay. Can anyone tell me what does these alpha actually imply to the loss function? See, what we are doing, we are basically doing this as a loss function, y minus y cap whole square. This is our loss function, right? I mean, these are the for every data point, I will just sum it up. Now, if I'm multiplying with the alpha I square, then what I'm actually doing?
Sir, multiplying rate,
Sorry, multiplying, that means?
learning rate.
Um, Maybe we are increasing the error.
Okay, okay. So increasing the error, but okay, got it. You can just whatever idea you people have, you can just speak, and I will just summarize later on. Okay,
Sir,
anyone else?
alpha is a parameter over here.
Alpha is some constant which might vary based on the data points. For some data point, I'm keeping it 1. For some data point, I'm keeping it 5, like this.
Sir, if we want to take some errors more seriously, we want to penalize them, then we can increase the alpha of that. And for some points, if you want to, let's say, ignore the error or suppress the error in the final term, then we can have a lower alpha there.
Very nice, very nice. Okay, so Rahul has given very convincing answer. So Rahul has said that what this alpha is implying, basically, that we are trying to say that, see, if this alpha is 10, that what we are trying to say, that, see, if you by chance make any mistake on this point, let's suppose on this point, okay, whatever prediction I'm doing, I'm taking this point extremely seriously, which means if I'm making any mistake on this point, will I will be able to reduce the see, what is my overall goal? overall goal to have the least error, right? I want to have the minimize of this. So if I want to minimize this, then what will I do? What is in my hand to tweak or to change? In my hand, I have the weights, right? W1 on W0. So what I will do, I will make sure that this particular example is fitting perfect. I'm taking this very seriously because little mistake on this. So basically, what is the weight of this particular example? Can anyone tell me? Alpha e square, which is 100, right? 100 into by 3 minus by 3 cap, right? Plus, 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 uh, basically this is 2, which means it is 4 into y. So basically what I'm trying to say, let me just go to the next page. So plus 4 into y, 4 minus y, 4 cap. No, there is no non-linearity or anything. Okay, it has nothing to do with the non-linearity or anything. Okay, it's very simple interpretation that you should be knowing. So this is 1 into y1 minus y1 cap plus 25 into y2 minus y2 cap plus this. So suppose I have two options. Suppose in one of the option I keep it as 1. The difference is, let's suppose, 1. In another option I keep the difference as 5. Which option is better? And in one option, let's suppose I keep this as difference. Okay, I hope I'm not confusing you as 1, and this is 5. So how many pairs you have? I mean, let's suppose I have multiple choices, which means I have this as one pair. I can make both as 1, but let's suppose, okay, sorry, let's suppose this is not in my hand. So I have, let's suppose, just two pairs, which means either I can make this as 1 and this as 5. I mean, this whole thing as 1, this whole thing as 5, or let's suppose I can make this whole thing as 5, this whole thing as 1. I have two choices. Which choice you will prefer? Which choice you will prefer? The first one, right? Because if you take this as 1, then it is 100 plus 20 only. 120. I want to minimize my loss, right? So it will be 120 only. I'm just ignoring these two for now, or just for the simpler explanation. It will be 120. And and if I take this as 5, it will be 500 plus 4, which is 504, right? So just making this as 1 is not very useful. This is 504. Making this as 1, but making this as 1 is actually very useful. Are you getting my point? So alphas are like giving the weightage, which means I cannot afford to I can say, like, have the bad prediction on this, right? I cannot afford to have bad prediction on this data point. If the alpha is too high, I will make sure कि कुछ भी हो जाए, बाकी सब भाड़ में जाए. Okay, I want to make this prediction very correct. Okay, whatever is okay with everyone else, but if let's suppose this is let's suppose 1,000, I will make sure that I don't make any prediction, any wrong prediction on this. Okay, I will definitely make sure that I don't make any wrong prediction on this, because I'm giving very, very good weightage to this particular data point. So here these alphas are saying that, okay, this particular data point is how much important to me. Okay, suppose if I want to do it, right? No, there is no way to determine it. So yes is asking how the alphas are determined. There is no way to determine, in the sense that you can have manual fix, or you can have your own prediction, whatever you want to do. I mean, that's another sort of a story. Okay, let's not worry about it. You can manually put any values based on the observation or something, right? But is this fine to everyone? That what does this alpha mean? Yes. So basically, it is the seriousness. Like, I cannot afford to mispredict on this. So as one of the student, what was his name? Yeah, Ijaz. Ijaz is saying that it is like important topic in the exam. If you miss it, determined to fail. Yes. So just something like this, right? So basically, you can't afford to miss it. Is this fine to everyone? Okay. So it is like weightage. You can't afford to miss it. If we are using it in the training data, why will we predict it? No, you are using in the training data to make sure that you are learning, right? To learn the parameters. Okay. To learn the parameters. Obviously you want to minimize. Ultimately, what is the objective? The objective is to minimize the loss function, right? This is how we are learning our W's. Okay. So mathematic, if you see the mathematical structure of the formulation, it means that I want to minimize on this loss function. So if alpha is too high for something, then I want to make this as low as possible, because otherwise high into high. If this is high, then this is also high. It will blast, right? High into high will blast. Is this fine to everyone? It is just like giving a weightage. If you want, you can call it your own linear regression. I mean, see, you are always allowed to do any changes in machine learning, in the sense you have just changed your loss function, okay, which is definitely fine. Okay, it's not an issue. In fact, when I was having the interview at Amazon, at that time they asked one question, which was very easy question, and you will also be able to answer that question when I will teach you logistic regression. So it was related to logistic regression, and they asked me just a simple question, that how will I make sure that I cannot tell you the question currently, because you won't be able to understand that there were like, it is for classification, there were like some points that we need to classify. So they were saying that how will I make sure that, okay, these points don't get misclassified or something. So I said, what we can do, we can make more weightage to these points. That's all. In the loss function, we can make more weightage to these points. Okay, that was the simple answer, and it was asked in the Amazon interview. Okay. So have you understood what is alpha? I mean, for this particular question, it is not necessary to know what is alpha. I'm just asking. In general, have you understood, if I'm multiplying, let's suppose, some alphas based on alpha I, based on the data point, it means I'm giving some weightage to the data point, right? Now, for this particular question, it is just a mathematical question. It doesn't ask you to know the meaning of the alpha, but that's fine. So what they are saying, can you just tell me what is the correct answer? See, the answer is the same as previous, I think. Okay. So this is just alpha I square you need to multiply, right? So it will be, I think, alpha I square everywhere is there. And then if you differentiate, let's suppose, with respect to this is with respect to W1, right? Then 2 into alpha 2 will anyway go to 0. And then what is the answer here? Yes. So D is the correct answer. Yes, great. So D is the correct answer, right? Okay. Let me know if there is any doubt. Anurag is asking, I understood that we need to give more weightage to third in the previous case data point, so that if someone give same data point, we cannot make mistake. Uh, yeah, you're right. Maybe I'm giving more weightage to this, maybe because of some reason, right? One of the reason that you mentioned, that in future, if in the test also the similar kind of pattern come, I don't want to take any risk. For example, this is very serious case for me. For example, let's suppose uh, I'm having, some house price prediction, okay, and I want to make sure that the house which are newly built, matlab, if the house is old built, then probably, let's suppose, okay, I'm just giving you an example, don't mind it, okay. So I'm saying that, let's suppose if the house is, the old, and it is, let's suppose, it is built in, let's suppose, 90s, okay, then probably, let's suppose, I'm not giving much importance to the house. But if the house is newly built, I don't want that particular landlord to make some loss, right? I want to make sure कि यार मतलब नया, he has just built a new house, he should be getting good money in the return, right? So probably based on that, I can make sure that, okay, for those particular, I don't want to make any misprediction, right? Probably, I mean, it is depending on the person, the data set to data set, the domain to domain. Why you are keeping this alpha too high for this particular example? It is the only thing that you know. Okay, maybe because of the domain is such that. So Yashasvi has given one example. She is saying that cancer patient that has very strong symptoms. So yeah, so you want to detect some, disease, and you say that, okay, if the person is already having the cancer, I don't want to miss that person, right? Or because of that, I'm giving more weightage to such data points, or whatever is the reason, that is up to you. Okay. Cool. So whatever is the reason, it is up to you. It's not like that anyone can tell you. It is up to you. For that reason, you can keep the alphas high. okay, if you want to. Otherwise, in practice, I don't think people do it, okay, because generally it is not possible, because we have thousands of examples. It is not possible to predict the alphas or to manually set the alphas. So generally, people, I have not seen in linear regression it is very popular, but you should know it, okay. Okay. So now let's just solve this question. You want to estimate a quantity y as a function of x. So they are saying y cap equal to, instead of theta x or wx, sorry, this theta and w are same. I hope you people are okay with that. I mean, this is just a parameter name. So they're saying y cap equal to theta of x, theta square root of x. Suppose you decide to model like this, okay, where uh, instead of x you are using square root of x, right? Note that our model has one parameter theta, and here is our data. Find theta cap or theta star. Some people write theta star as a optimal solution, or some people write theta cap or w cap. Then minimize the mean square error. Okay, is the question understood to everyone? So instead of x, they are using x cap. Oh, sorry, square root of x. So let me do one thing. Let me just just take the square root, and let's just see what is happening. Okay, so let's just take the square root. So if I take the square root, then you will be getting something like this. Let me write it. Okay. What is this number? I think this will be 3, 2, and 1. Is this okay to everyone? Can I call this square root as some other x, maybe x prime or maybe just x? Okay, or who cares? Isn't it? Is this fine to everyone? Right? So actually, I can even again call it x only. Okay, I mean, it's not an issue. You can keep it. You can say x prime or something. Okay, but if you want, you can just say that. Okay, this is just a feature transformation. I mean, I have changed my feature from x to square root of x, right? If you want, you can again say this as x, or if you want, you can say it as x prime. By the way, tell me, is this a linear regression? Is this a linear regression? How many of you think this is a linear regression? Okay. Yes, this is a linear regression. Okay. I just changed my feature. Changing the feature doesn't say that it is not a linear regression. Okay. This is definitely a linear regression. So here, instead of using x, I'm using some other feature. That is square root of x. It could be x square, could be x cube. Still, it is a linear regression. Right? So linear means here this is linear in the sense it is linear in theta or linear in w. Okay. So here it is not linear in x. That you need to understand. So this is also linear regression. Okay. If you are thinking this is not linear regression, actually this is also linear regression only. Understood? Let me know. Okay. Yeah, we will see some example with w square also. Okay. It won't actually matter, right? We will see some example with w square also, but it won't actually matter. You can again keep it as some w. Okay. So now let's just find out what is our best theta. How to find out? What you can do, you can just find out the mean square error. Which means for x, for example, for x equal to 3, right? You need to do y minus y cap whole square, right? So y is 2 minus y cap. Y cap is actually theta, 3 theta, right? Whole square plus 1 minus 2 theta whole square plus 0 minus theta whole square, right? So this is your loss function. Now you can definitely find out the gradient of this. which is 2 into 2 minus 3 theta into minus 3 plus 2 into 1 minus 2 theta into minus 2 plus theta square. This is just theta square. So plus 2 theta, right? You can keep it to be 0 and then you can find out what is the value of theta that you're getting. Okay. Okay. So if you do it, then I think you are getting as 4 by 7, right? So doing this constant actually won't matter much because ultimately anyway we do it to 0. So you can write anything here, which means you can write 1 by n, 2 by n, 5 by n, 1 by 2 n, anything, right? Because the constant will anyway vanish, right? Ultimately, to find out the optimal solution, this constant doesn't matter. Okay. So 4 by 7 is the correct answer. Now let's do this question. What they are saying, we would like to use the following regression function where x is a single value variable given a set of training data points, derive a solution for w. So here they are saying that what is the w that you are getting. So what we need to do, sorry, what they are saying, given a set of training points. Okay, so these are the training points xi and yi. Okay, so we need to drive the solution for w. So what you can do, you can just write y as w square plus w, okay, into x. So y is written like this. You can just write like this. Now you need to minimize by I minus or y I, yeah, yi minus. You can call it y cap actually, just to not get confused. Okay, the predictions you can call it cap. Yi minus yi cap whole square. So what is yi? Yi is just yi minus yi cap is w square plus w into xi whole square, right? This summation for I, it should be 0. Sorry, this is your loss function, right? Now what you need to do, you need to differentiate it and put it to be 0 to find out w square plus w. Or maybe you can just call it some w prime for now. And then if you do it, then your w square plus w or the w prime will be summation of, or let's just quickly do it. So you can call it as w prime, then 2 into yi minus w prime xi into, if you differentiate with respect to w prime, I think minus xi, right? This summation should be equal to 0. Okay. And then this minus 2 will go to anyway to 0. So it will be xi yi, right? Minus w prime xi square. This summation should be 0. So which is same as saying summation of w prime xi square is equal to xi yi, which is same as saying xi yi. So this w prime will be summation of xi yi divided by xi square. Yes, xi and yi both are the data points only. Okay. Is this fine to everyone? Okay. So it is a simple calculation. Can we cancel xi? No, you can't cancel it because this is within the summation. It will be x1 square plus x2 square, and it is just x1 equal to x1 plus x2, something like this. Okay. It is linear. I mean, x1 by 1 or whatever. You just can't cancel it. It's not possible. Okay. You can cancel only if whenever you have doubt, just try to open it for one or two values. Okay. Then you will get to understand. Right? Can you cancel x1 in this equation? If this is, let's suppose, x1 y1 and x2 y2, can you cancel x1 here? No, right? So you can just open up just for one or two, just for two, and then you will get to understand whether you can do your things or not. Okay. Okay. Suppose they are saying we would like to compare the regression model used in one. Actually, this was just one. Let's suppose. Okay. Sorry. This is one. So they are saying the regression model that we have used in one. I want to compare it with this following regression model. Here I'm just using W. Okay. So given the limited training data, which model would fit training data better? What do you think? Model one, model two, both will fit equally. Given limited training data, which model would fit the test data better? What is the answer? See, there W square plus W and here W both are same, right? Here, if you check it, then this W will be the same thing, which means summation over xi by I divided by summation over xi square, something like this. Okay, this W will also come out to be the same thing. So, will the prediction matter to me? I mean, will the prediction differ? No, right? Model 2 is this. This is model 2. Model 1 was earlier one. What is the model 1? Okay. Just to make sure that you are not getting confused, I'm keeping y cap. Generally, people write it y, but it is very much obvious to understand that it is actually y cap. It is the predicted one, right? Okay. So this W square plus W and ultimately this W both are same, right? Ultimately, the answers here, whatever you are replacing, and here also whatever you're replacing with the same quantity. So that is why in both the cases, three is the answer, right? In both the cases, three is the answer. Three, right? Here also three. What is the reason they have mentioned? As mentioned above, the solution to the optimization problem is the same, and so the outcome will be same as well, right? The solution to the optimization problem is same. Any value can be expressed using W, can be also expressed using W square plus W, and so two models are exactly same. Okay. So there was no benefit in using some W square plus W or something. Now let's just solve this question. What they're saying? They're saying that consider this data set is given to you. Again, we are currently in the 1D format only. Let's suppose that we have the 1D data set only, right? What is the mean square error if you use this hypothesis, which is, let's suppose, 2x, y cap equal to 2x? Value of W won't increase. Increase means why you will increase it? In both cases, you will be replacing with the same quantity. The final answer of W and W square plus W was same, right? Okay. Now let's just solve this question. So what they're saying, what is the mean square error on this if you use y equal to 2x? Okay, so this is 1, 2, 3, 4, 5. Sorry, 5 is missing, 4, 6. So if you use y equal to 2x, can you find out the error? So what is the predicted for 1? For 1, what is the predicted? 2. For 2, what is the predicted? 4. For 3, what is the predicted? 6. For 4, what is the predicted? 8. For 5, there is no data point. For 6, what is the predicted? 12. So you can just see the difference. This is predicted, this is real one. 1 square, right? So it is 1 square plus this is predicted, this is the real one. 0 square plus this is 6, this is also 6. So 0 square plus 2 square plus this is 12, this is 6, which means this is 6 square divided by how many points we have? 1, 2, 3, 4, 5. 5. So this is 36 plus 4, 40 plus 1, 41 upon 5. Okay. So 41 upon 5 is the answer for part A, right? It is easy question. I hope you understood it. Let me know. So predicted and the real one which are given to us, right? Now let's do the interesting question, which is the second one. So they're saying Beatrice decided that for her application, small errors in the predicted y values are irrelevant. So she decided that she can design a new loss function by altogether, which means she is assuming that, let's suppose, if my predicted one is within the range of 2 of the real one, which means if it is 2 lesser or 2 higher, then my loss is 0. Otherwise, my loss is not just the difference square, it is difference minus 2 whole square. Okay. So can you find out this? Can anyone tell me what is the answer here? So basically, that person, okay, Beatrice, has decided to change the loss function by altogether. Can you change the loss function? Tell me, is this okay? Have we changed the loss function earlier also? Yes, right? In which example? In the example of alphas, right? Yes. So you can change the loss function by yourself. It's not issue. Actually, whenever you are solving any good question or any good problem statement, at that time probably I'm not saying 100%, but probably you need to tweak your something into the loss function. Okay, based on the requirement. Okay, you can definitely do it. For example, when I was working at Amazon, I have tried different loss function with little bit of change. मतलब फॉर एग्जाम्पल मुझे लग रहा था कि यार फॉर एग्जाम्पल कि कुछ भी चेंज करते थे यार मतलब फॉर एग्जाम्पल लेट सपोज वाई इज गिवन टू मी ओके एंड आई वाज थिंकिंग कि दिस इज टू हाई वैल्यूज इन वाई एवरीथिंग इज टू हाई वैल्यूज लेट मी डू वन थिंग let me subtract 100 okay even before start my machine learning models let me just change the data I mean let me just subtract 100 and ultimately when I get the prediction I will add 100 later on okay matlab whatever is coming to your mind and if that is justified that is logical you can do it so I'm just telling you one thing that I did was I was just solving one problem statement and that y was let's suppose in the range which I was not liking or my machine learning model was not performing good. So I did what? I subtracted 100 before even feeding into machine learning model, and then whatever machine learning model gave me as an output, I just added 100 later on. Okay. So anyway, whatever is coming to your mind, you can do it as long as it is logical. So definitely you can change the loss function. It is up to you. So that person has decided to change the loss function. Then tell me quickly what is the answer you're getting. So Arnav is getting 16. Okay. So let's just see. For this 2, what is the answer? What is the predicted one? Predicted is again 2 only. I mean, this is the hypothesis or the model is same. Only the loss function is different. Okay. Suppose for x equal to 1, this is the predicted one, real one is 3. So real one and predicted one, are they within the range of 2? Tell me. I mean, 2 and 3 difference is just 1, right? So within the range of within the range of 2, right? So it means that what is the loss for this particular data point? For this particular data point, what is the loss? Loss is 0 because if this is within 2 plus minus 2, then I will say it is 0 plus. For the second point, this is 4, this is 4. Anyway, it was 0 earlier also. Plus for third point, this is 6, this is 6. Okay, anyway, earlier also 0. Plus for fourth point, this is 8, this is 6. So now you tell me what is the, is it within the 2? I think yes, right? It is again within the 2, so you can again make it 0. And then if this is 12, if this is predicted is 2 wrong, okay, predicted is 2 wrong, then I'm saying, okay, then let me just penalize it, okay? In that case, I'm saying if this is 6, the difference is 6, then the difference, and I'm not even penalizing it too much, I'm penalizing it 2 lesser, okay, which is fine. So 6 minus 2, 4. So 4 square, okay, divided by 5. If you're asking for average, okay, which is 16 by 5. Great. Okay. So some of you have given the correct answer. Y cap is not X. Yes, Y cap is 2X. That's correct. Here also it was 2X. Okay. Have I said X somewhere? Okay. So by the way, this is a good question, right? This question I've taken from MIT. Okay. So these questions, as you can see, that there are obviously many other questions to solve this, but are you guys enjoying these questions? So these questions are basically just to make sure that you know linear regression in its entirety. in the sense that that you can have the feel of linear regression, which means if we are tweaking the loss function, let's suppose you are having some weight to the loss, okay, for example with the form of alphas, then what changes it might be doing, some other loss function you are doing, or whatever the questions we are doing, it is ultimately making your understanding better about the algorithm, right? And also not just algorithm, in general machine learning. Okay, I think tweak means change, right? Tweaking something means change. No, straight line is given by y equal to wx. Straight line and loss function are not related. Okay, loss function curve could be anything. As I told you in the last class, loss function curve was like this, right? Loss function curve could be anything, but your line is straight will be given by this, right? It will be given by this. If your line is straight or not. Okay. Okay. Now, this question is a small question. Don't worry. It seems just like, just for the formality, it is too big. Let me quickly read it. And then I have actually written the short form of this. If you want, I can directly read out the short form. But anyway, let's just quickly read it. Consider a modification to the standard linear regression setup where each data point is associated with the important weight. Okay. For example, they're multiplying each data point with Ri. By the way, they're having the superscript instead of subscript, but I hope that's fine. I mean, they've given that these are the examples. Okay, is this fine to everyone that they're using superscript instead of subscript, right? Okay. So now what they're saying, we are using Ri as some weight. Okay. The diagram below shows a training data set and with the three examples. Okay. So basically, there's a diagram in which you are having three examples, right? Now, what they're saying here, the input X are one dimensional. That's fine. Soumya. Okay, that's great. They've used Indian name, right? Okay, this is some foreign university. They've used Indian name. This is good to know. Okay. Soumya chooses some important weights R1, R2, and R3 and train the model to minimize the WRSSS. They are calling it some weighted residual sum of a square. But anyway, this is some loss function that we are trying to minimize. The model's prediction are illustrated with the original orange line. Okay. So actually, let me just summarize the question. This is the summary of the question. मतलब कुछ ज़्यादा है नहीं. They have defined their own loss function. Now they are saying that these values Ri, these values are chosen by some person. Okay, Soumya has chosen these values, and Soumya want to train her model on these three data points, right? Now, finally, she has learned that, okay, this is the line that we are getting. Okay. So after training is done, everything is done, and this is the final best fit line that she is getting. Okay. This is the best fit line she is getting. And which is the final one. What they're saying, what are the values of W and B? Okay. So you can definitely tell. These are the 2 points by which it is passing, I think. Okay. This is the first point, and I think the slope is 1. So B is 1. And it seems to be, I think that's the only way. Probably they have missed to write something. The value line is given with the equation, so we can see from the graph. From the graph only you need to observe. Anyway, W is coming out to 1 by 2. Okay. Probably they will give them more information that what is this X3 and all. But don't worry about it. Okay. This is important question. Just see this. Out of the values of R1 and R2 and R3, that Soumya choose, which was the smallest? And explain your reasoning. Which one you think is the smallest? So Soumya is choosing R1, R2, R3, and finally she is getting this line. Which you think that is the smallest value? Yes. I'm really very happy to see that everyone is giving the correct answer. Okay. So you people have given the correct answer. Let me just copy paste it. That yes, R1 is the answer here. Okay. So R1 is definitely the correct answer here. Why R1 is correct answer? Because as you can see that here I'm giving least important to this. I mean, even if it is having very bad prediction, I'm fine with this, right? I'm fine even if it is having very bad prediction. So it is clearly visible that okay, I don't care about it, right? I don't care about it. So that's why from this graph you can see the R1 is having the least one, right? So R1 must be the smallest because the model has very large error on x1 by 1 compared with the other examples. This means that example 1 is the least important example to me, which corresponding to the smallest R1, right? Now you understood what is the weightage of the data point. Have you understood with this particular question? Okay, how we got W equal to 1 by 2? Actually, they are missing the information. They should give something, okay? They should give at least x3 by 3. 2 points तो चाहिए ना? At least एक और point तो चाहिएगा कि किससे ये पास हो रहा है. I don't know the values of x3 by 3. They should give it, okay? They just missed it, but that's fine. Okay. Now let's just do this question. What they're saying, explain in 1-2 sentence how allowing Ri less than 0. Let's suppose I allow, okay? I mean, see earlier, do you remember I kept it alpha e square, right? I was making sure it was positive. But they are saying, suppose I say that Ri is less than 0, okay? For some I, how allowing Ri less than 0 for some I could lead to undesirable behavior. Do anyone wants to speak? If I keep Ri less than 0 for, let's suppose x1, how it could be disastrous to us?
सर देन अगर एरर जितना ज्यादा होगा तो हम उसको ज्यादा फेवरेबल मानेंगे तो
राइट, एरर जितना ज्यादा होगा उस पर्टिकुलर डेटा पॉइंट के लिए ना.
हाँ
हाँ, ओके. तो उसके आगे मतलब आपका सही है, उसके आगे आप यू वांट टू ऐड समथिंग?
तो वो उतना अच्छा हम उसको मानेंगे तो अच्छा वो नहीं होगा मॉडल.
Right, right, right. Okay, so Ijaz is also saying that it will further decrease the error. Yes. So basically, let's suppose that I'm saying that R1 is 1. Okay, for example, let's suppose I'm saying R1 is 1. Why it is disaster? Sorry, -1. Why it is disastrous to have minus value? Because ultimately I want to what? Minimize or maximize my loss function. I want to minimize my loss function, right? This is my loss function, which ultimately I want to minimize. Let's suppose I keep it -1 here. Then what is the best value for this? The remaining part? What do you think? This is the error square, right? This is, I want to keep it infinity. Okay, ideally मैं इसको जितना ज्यादा रखूंगा उतना फायदा है, isn't it? Right? Do you agree with me? Let's suppose I keep it 5,000. Isn't it better to me? Because 5,000 into -1 is very less. -5,000, right? I keep it 50,000. Isn't it very good to me? -50,000. Because ultimately it is -50,000. I want to decrease it. Overall, I want to decrease. Remember, overall, I want to decrease. So if it is minus, I will increase this, right? I will keep it 5 lakh because overall it will be minus. It is contributing -5 lakh, right? So if what I'm trying to say that if this is for this R1 equal to -1, then I will keep my line as far as possible from this particular point. I want to make sure, I will definitely make sure कि इसका जो error है ना वो maximize हो, ताकि correspondingly, like if this is very very high, if this is very very high, then correspondingly ultimately is very 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 low, right? Obviously I will have to make sure that these are also not too high, because these are anyway positive, right? If these are also too high, then it won't be useful. So basically keeping these as low, okay, keeping these for these 2 points, keeping as low as possible, and then keeping as high as possible from this and as low as possible from these two, right? I have to balance, but anyway it won't be a good fit. Do you think it will be a good fit? I'm unnecessarily keeping, I'm going far from this. Is this a good idea to go far from this or from any point? Obviously no, right? Obviously no. So why would I have the bad model, okay, which is actually going far from some data point? So this is not a good idea, I think, right? So basically what they are saying, the loss decreases as the error on the ith example increases. So the model is incentivized to make as large of error on the example as possible. So on for that particular example, it wants to make as large as possible, while the results in this will result in the bad predictions, right? Understood? So I want to go, if R1 is -1, then I will try to go as far as I will try to move as far away as possible from x1 by, right? Obviously while keeping not too far from x2 y2 and x3 y3. Understood? Okay, so now let's just solve the C part of this particular question. What they're saying, let W star be any value of W that achieves the lowest possible value of the standard linear regression loss function in the class. Okay. So W star, they are saying that, I mean, the standard linear regression function where you don't have this Ri and all. Okay. And W tilde, they are saying, let's suppose W tilde be the value that is the optimal value when Ri equal to 10 for all I. Okay. So suppose they're fixing it to be 10. Okay. Now, if you solve this, you are getting optimal as W tilde. And the ideally, whatever we have, okay, without this Ri, we have W star. Now, what they're saying, assume the normal equation. Okay, so currently, I think in context of linear regression, I haven't talked about the normal equation. But yeah, after differentiation, whatever you get is the normal equation. Anyway, while we go to the higher dimension, we will again talk about the normal equations. So I hope you know that how we achieve normal equation, right? We need to differentiate with respect to W and with respect to B. And whatever we get here, we call them as normal equations. Do you remember? Little bit you might remember, right? So whatever we got, these two equations, system of linear equation of these two are called normal equation. Or in other words, if you use, if you choose to use in the matrix format, then you get, if you remember, in case of Ax equal to B, we were getting A transpose Ax equal to A transpose B. This was the normal equation. Do you remember? Right? So similarly, I mean, after differentiation, whatever we get, that is called normal equation anyway. So you might remember that this equation we were getting after differentiation. Do you remember that this equation we have got after differentiation only, right? So we will again talk about the normal equation when we go to the higher dimension, but let's just solve this question here because it was in the continuation of the previous parts. So what they're saying, that let's suppose W tilde is the solution of this, W star of the solution of the normal mean square error, right? It is basically the solution of normal, I mean, the usual mean square error. Now, suppose that you have the unique solution, then W star and W tilde be the guaranteed to be the same. What do you think? You have the unique optimizer. Yes, actually, it won't matter whether you are multiplying by the 10 or you are not multiplying by the 10, because this 10 is just constant and it will anyway vanish, right? It will anyway go to the 0. So if you're minimizing some function, right, you can say whatever value of x minimizes, the same value of x will minimize this. Okay. Any constant as long as it is positive. So I need to write some positive number. I'm writing 10. Okay. Do you understand what this argmin mean? Okay. Can I write like this? Can I write like this? Is this correct? Is the second one correct? The second one is wrong because the minimum values are not same, but argument which is minimizing both are same actually, right? The first one is actually correct. I hope it is clear to everyone. So multiplying with some constant doesn't harm you anything, right? So if you're multiplying by 10, so and on top of that, if you have unique minimizer, so it actually won't matter. So yeah, that is okay, which means W star and W tilde is same. Now they are saying, suppose you have multiple minimizers, okay? Normal equation has more than one solution. Does this change your answer? In this case, can you claim that W star and W tilde will be same? Actually, here you won't be able to say. It is not because of 10. Okay, 10 से तो कोई फर्क नहीं पड़ता. It will anyway get vanish. It will anyway go to 0 when we are differentiating. Do you agree with me that 10 don't matter, doesn't matter? Because whenever you're differentiating, this will anyway vanish, right? It will anyway go to 0. It is not because of 10. It is because of the nature of the problem, you can say. So if you're having multiple minimizers, then obviously one minimizer can be W star, one minimizer can be W tilde. So you can say that here whatever is the minimizing, it might not be same. Yes. If there are more than one solution, which means if you are having, let's suppose, these equations, right? So these set of equations can have more than one solution also, which means equally good fit. Um, for example, let's suppose, okay, I'm not sure if it is, I mean, if it will be the best fit or not, but assuming this is a data set, in that case, okay, suppose this is the data set. Right, in that case, let's suppose, I'm just assuming, I'm not sure that whether it is correct or not, but suppose this is the minimizer, this is the best fit. Okay, do you think there will be any difference between this and this? Assuming that this is the best fit, then see here, it is this much far from these two, and this is this much far, right? And similarly, this also having the same property, right? So there are multiple best fit, right? There could be multiple best fit. Okay, so if there are multiple best fits, so in this case, which one is W star and which one is W tilde? Actually, you can't comment, right? Maybe both are same, maybe both are different, right? If there are multiple best fit, then W star could be one of the best fit, W tilde could be another one of the best fit. It is not because of the 10. It is because there are multiple solutions. You can't say which one is W star, which one is W tilde. Maybe both are same, maybe both are different, right? So here they has to be same, because if there is just unique minimizer, they has to be same. This does change the answer. Now W star and W star are not guaranteed to be same. They could be same actually. Okay, so don't worry about the further explanation. Maybe you will not understand, because in the context of linear regression, I haven't talked about these kind of matrices. I've talked about A transpose A, which is same as X transpose A. But anyway, I will talk about it later on. I mean, in the multivariate. But since it was in the continuation, so I hope you understood, right? Is this okay to everyone? That here they has to be same. Here maybe this or may not be this, right? Is this because of the 10? No, 10 will anyway get vanished. It is not because of the 10. It is just because that we have multiple solutions. One of them can be W star, one of them can be W tilde. Both of them can be corresponding to the same fit, or can be corresponding to the different fits, right? Let's see this question, which is very interesting question. So what they're saying, using monthly stocks averages x1 to xn. Okay. So basically, this is some data which is with some scalar, which is the average of monthly stock, I think. Okay. Anyway, like the domain knowledge doesn't matter. That what does this mean actually doesn't actually matter. So what they're saying, you run a linear regression without don't worry about the regularization. We will study this further. Okay. Uh, but you run a linear regression to further predict that what is y. So basically, they are saying you have n examples. Okay, sorry. I think, Okay. Let's just skip this for now because it is not the example. No, not the. These are not the examples. These are actually the features. So it is a multivariate question, multivariate linear regression question. I missed it and I put it here. But anyway, let's just have the similar question. Suppose in the single variate, let's suppose